Grounding requirements for generators at pump stations depend on the specific electrical system. Firstly, consider a pump station with a 480 delta 3-wire system that has no ground. In this scenario, installing a ground rod at the trailer-mounted generator is recommended. The utility system lacks a return path, so the generator frame needs grounding to establish a reference point for the electrical system. This grounding helps protect personnel and equipment in the event of a fault. Secondly, consider a pump station with a 4-wire 277/480Y system where the neutral is unbroken in the transfer switch. In this case, it is not recommended to install a ground rod at the trailer-mounted generator. The neutral wire is directly connected to the generator frame. The generator frame is already grounded through the unbroken neutral and the ground rod at the service entrance. Installing an additional ground rod would create a parallel ground path, which is generally not recommended by experts. Here is a summary of when ground rods are needed. Firstly, for a 480 delta 3-wire system with no ground, a ground rod is required. Secondly, for a 4-wire 277/480Y system with an unbroken neutral, a ground rod is not required. It is important to note that the generator manufacturer's instructions may not always align with the specific requirements of the electrical code in your particular area. It is always advisable to consult with a qualified and licensed electrician to ensure compliance with local codes, standards, and regulations. Understanding grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to return to the source, allowing overcurrent protection devices such as circuit breakers or fuses to operate and clear the fault. Bonding connects all non-current carrying metal parts together to create an equipotential plane, minimizing voltage differences and reducing the risk of electric shock. Grounding electrode system. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or underground metal water pipes. These electrodes are connected to the equipment grounding conductor system and the neutral conductor in some systems to provide a low impedance path to earth. Ground rod installation. When installing ground rods, it's important to follow the electrical code requirements for depth, spacing, and connection methods. Typically, ground rods must be driven at least 8 feet into the ground and spaced at least 6 feet apart. The connection between the ground rod and the grounding conductor must be made with a listed connector or by exothermic welding. Parallel ground paths. Parallel ground paths can occur when multiple grounding electrodes are connected to the same electrical system. While this might seem like a good idea to improve grounding, it can actually create problems. Parallel ground paths can carry circulating currents, which can cause nuisance tripping of overcurrent protection devices, increase electromagnetic interference, and create safety hazards. Grounding in delta systems. In a 480 delta 3-wire system, there is no neutral conductor. The system relies on a corner-grounded delta configuration, where one of the phase conductors is intentionally grounded, or an ungrounded delta configuration, where none of the phase conductors are grounded. In either case, a ground fault on one of the phase conductors will cause a high fault current to flow, which can damage equipment and pose a safety hazard. Grounding in Y systems. In a 4-wire 277/480Y system, the neutral conductor is connected to the center point of the Y configuration. This provides a grounded reference point for the system. The neutral conductor is typically grounded at the service entrance and at the transformer. This grounding helps to stabilize the voltage and provide a path for fault current to return to the source. Transfer switches. Transfer switches are used to transfer the load from the utility power to the generator power during a power outage. There are 2 types of transfer switches. Firstly, manual transfer switches, and secondly, automatic transfer switches. Manual transfer switches require manual operation to switch between the utility and generator power. Automatic transfer switches automatically switch to the generator power when the utility power fails and automatically switch back to the utility power when it is restored. Neutral switching. When using a transfer switch with the generator, it is important to consider whether the neutral conductor should be switched or left unbroken. If the neutral conductor is switched, the generator must have its own grounding electrode system. If the neutral conductor is left unbroken, the generator can rely on the grounding electrode system at the service entrance. Ground fault protection. Ground fault protection is designed to detect and interrupt ground faults. Ground fault protection is typically required for large electrical services and for equipment that operates in hazardous locations. Ground fault protection can be provided by ground fault circuit interrupters, ground fault relays, or other devices. Surge protection. Surge protection is designed to protect electrical equipment from voltage surges caused by lightning strikes, utility switching, or other events. Surge protection devices are typically installed at the service entrance and at individual pieces of equipment. Electrical code requirements. The electrical code contains detailed requirements for grounding and bonding. These requirements are designed to ensure electrical safety and prevent electrical hazards. It is important to consult the electrical code and follow its requirements when installing or modifying electrical systems. Qualified electrician. It is always advisable to consult with a qualified and licensed electrician to ensure that electrical systems are installed and maintained safely and in accordance with the electrical code. A qualified electrician has the knowledge, skills, and experience to properly design, install, and maintain electrical systems. Generator sizing. When selecting a generator for a pump station, it is important to properly size the generator to meet the load requirements. The generator must be able to provide enough power to start and run all of the equipment at the pump station, including the pumps, motors, and lighting. Generator maintenance. Regular maintenance is essential to ensure that a generator operates reliably. Maintenance should include inspecting the generator for damage, checking the oil and coolant levels, cleaning the air filter, and testing the generator under load. Load calculations. Load calculations are used to determine the electrical demand of a building or facility. Load calculations take into account the size and type of equipment, the usage patterns, and the diversity factors. The results of the load calculations are used to size the electrical service, the feeders, and the overcurrent protection devices. Voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or fail. It is important to size conductors properly to minimize voltage drop. Conduit fill. Conduit fill is the percentage of the cross-sectional area of a conduit that is occupied by conductors. The electrical code limits the amount of conduit fill to prevent overheating of the conductors. Overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Overcurrent protection devices must be sized properly to protect the conductors and equipment in the circuit. Wiring methods. The electrical code specifies the acceptable wiring methods for different types of installations. Wiring methods include conduit, cable, and wireway. Each wiring method has its own advantages and disadvantages. Hazardous locations. Hazardous locations are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dusts. The electrical code contains special requirements for electrical equipment and wiring in hazardous locations. Electrical safety. Electrical safety is the practice of working with electricity in a safe manner to prevent electrical shocks, burns, fires, and explosions. Electrical safety includes using personal protective equipment, following safe work procedures, and energizing equipment before working on it. Lockout/tagout. Lockout/tagout is a safety procedure that is used to prevent accidental energization of equipment during maintenance or repair. Lockout/tagout involves disconnecting the equipment from its power source and attaching a lock and tag to the disconnect switch. Arc flash. Arc flash is a dangerous electrical phenomenon that can occur when a high voltage arc forms between two conductors. Arc flash can cause severe burns, blindness, and death. The electrical code requires arc flash hazard assessments to be performed and appropriate personal protective equipment to be used when working on energized equipment. National Electrical Code. The National Electrical Code is a set of standards for the safe installation of electrical wiring and equipment in the United States. The NEC is updated every 3 years and is adopted by most states and local jurisdictions. Underwriters Laboratories is a product safety testing and certification organization. UL tests and certifies electrical equipment to ensure that it meets safety standards. National Fire Protection Association. The National Fire Protection Association is a non-profit organization that develops and publishes codes and standards for fire prevention and safety. The NFPA's codes and standards are used by fire departments, building officials, and other safety professionals. Institute of Electrical and Electronics Engineers. The Institute of Electrical and Electronics Engineers is a professional organization for electrical and electronics engineers. The IEE develops and publishes standards for electrical and electronic devices and systems. American National Standards Institute. The American National Standards Institute is a non-profit organization that coordinates the development of voluntary consensus standards in the United States. ANSI standards are used by industry, government, and consumers. Occupational Safety and Health Administration. The Occupational Safety and Health Administration is a federal agency that is responsible for ensuring the safety and health of workers in the United States. OSHA sets and enforces safety standards and provides training, outreach, and education to employers and workers. State and local regulations. In addition to the National Electrical Code, many states and local jurisdictions have their own electrical codes and regulations. These codes and regulations may be more stringent than the NEC. It is important to consult with the local authorities to determine the applicable electrical codes and regulations. Grounding electrode conductor. The grounding electrode conductor connects the equipment grounding conductor to the grounding electrode system. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. Equipment grounding conductor. The equipment grounding conductor provides a low impedance path for fault current to return to the source. The equipment grounding conductor is connected to all non-current carrying metal parts of the electrical system. Bonding jumper. A bonding jumper is used to connect two or more metal parts together to create an equipotential plane. Bonding jumpers are typically used to bond metal enclosures, metal raceways, and metal water pipes. Grounding and bonding of generators. When connecting a generator to an electrical system, it is important to properly ground and bond the generator. The generator frame must be grounded to the grounding electrode system. The neutral conductor of the generator must be bonded to the generator frame. Grounding and bonding of transfer switches. When using a transfer switch with a generator, it is important to properly ground and bond the transfer switch. The transfer switch enclosure must be grounded to the grounding electrode system. The neutral conductor of the transfer switch must be bonded to the transfer switch enclosure. Grounding and bonding of equipment. The electrical code requires that all electrical equipment be properly grounded and bonded. This includes motors, pumps, lighting fixtures, and other equipment. Grounding and bonding inspections. Electrical inspections are performed to ensure that electrical systems are installed and maintained safely and in accordance with the electrical code. Electrical inspections are typically performed by qualified electrical inspectors. Troubleshooting grounding and bonding problems. Grounding and bonding problems can cause a variety of electrical problems, including electrical shocks, fires, and equipment damage. Troubleshooting grounding and bonding problems requires a systematic approach and a thorough understanding of electrical principles. Electrical testing. Electrical testing is used to verify the safety and performance of electrical systems. Electrical testing includes insulation resistance testing, ground resistance testing, and voltage testing. Electrical safety training. Electrical safety training is essential for all workers who work with electricity. Electrical safety training should cover the hazards of electricity, safe work procedures, and the use of personal protective equipment. Reviewing specifics in pump stations. Let's re-emphasize the two scenarios at pump stations. Firstly, in the 480 delta 3 wire system scenario with no ground, the absence of a return path in the utility feed means the generator's frame becomes an essential reference point when it is operating. Driving a ground rod at the generator effectively creates this reference, offering a low impedance path to earth for fault currents, mitigating potential hazards. Secondly, in the 4-wire 277/480Y system, where the neutral connection remains unbroken within the transfer switch, the scenario shifts. Here, the generator's frame is already tied to ground via the continuous neutral and the service entrance ground rod. Introducing an additional ground rod risks creating a parallel ground path, a situation generally discouraged due to its potential to carry circulating currents which can lead to nuisance tripping and electromagnetic interference. Therefore, understanding the nuances of each system is crucial for safe and effective generator grounding. Consulting with a qualified electrician before making any changes will save you time and resources in the long run.